Okay, we'll see if third time's a charm on this sucker. Sometimes my QuickTime screen thing decides to go south, especially on a Friday when I'm trying to get the hell out of here. But anyway, so I've gotten an email already on the spider problem that's in your homework for, and what I want to start doing is maybe doing one problem or so out of each set and putting it on Top Hat so you can go, so you give explanations of it and things like that. So that's what we're doing here. And you don't need to see my mug. You know what I look like. All right. But here's a problem that is really close to the spider problem. In fact, it is the spider problem. And it's in your book. And it's on page in your book 148. Be in your book on page 148. And that's what we're going to use here. Okay, that's what we're going to use. We're just going to solve this problem. So let's go straight to the ladybug because I don't want to waste a lot of time doing this. All right, so here we go. Go to my ladybug here. Go to my ladybug here. Any day. There we go. All right, I've got it kind of set up here. All right, so I've got the 70 kilogram force. Got the two tight ropes here. This would be T2 and this would be T1. Now, just because each of these angles is 5 degrees, we pretty much can assume that T1 is equal to T2. Not according to my drawing, which is a little cattywampus, but it's still the same thing. So, here's another thing we're going to use. Let's draw another parallel line right across there. When I do that, if this angle is 5 degrees, then guess what? So is this one. If this angle is 5 degrees, so is this one. So I've got T2 looks like this. And just for clarity, I'm making the angle a little bigger, keeping it at 5 degrees. And so I've got T2x, T2y, and over here, T1x. That's T1. T1x, T1y. All right? So, sum of the forces in the y direction. Let's do the sum of the forces in the x direction. Well, nothing's moving, right? It's sagged and we're stuck, and we're just sitting there. So sum of the forces is equal to 0. Well, let's add up the forces we've got. We've got this equals T1x minus T2x equals 0. So therefore, T1x is equal to T2x. Well, T1x is equal to T1 times the cosine of 5 degrees. T2, which is equal to T2 times the cosine of 5 degrees. And this is nice because they had the angles the same. Otherwise, we'd have to, T1 would be a multiple. We'd divide by the angles to find out what T2 is equal to. Then we'd have to plug it back into the y thing. So on this one, we're starting in the x direction. So the cosines cancel. Cancel cosines. And we wind up with T1 is equal to T2. So we're going to use that information. All right? So we're going to use that. And we'll come over here and let's look at the sum of the forces in the y direction. That's also equal to 0. But we've got one extra thing. We've got the 70 kilogram trapeze artist, right? So we've got we got 0 is equal to T2y, which I'm going to just let T2 equal T1 from now on. All right? I'm going to let T1, so I've got T1 sine of 5 degrees plus T1 sine of 5 degrees minus mg. Oh man, this is going to be so nice. This is going to be so nice. So therefore, look what we have. This is nice. So I add mg to both sides. So mg is equal to T1 sine of 5 plus T1 sine of 5 because, again, I used that substitution I got in the x-coordinate, and I wind up with mg is equal to 2T1 sine of 5 degrees. So mg divided by the sine of 5 is equal to 2t1. So let's do one more thing. mg2 times, divide by both sides by 2. 2 sine of 5 is equal to t1. All right, and let's just figure out what that number, let's just take a look at what that number is real quick. Oh, shoot, I'm sorry, I should have my calculator out before I got started. You should have seen my first attempt at doing this. It was a disaster, but that's okay. So here we go, clear, and I've got 70 times 9.8, that's my mg right there, divided by, I'll put all this in parentheses, 2 sine 5, close that parentheses twice, boom, wow, that's a lot of tension in that rope, 3935, 3,935 newtons. That's pretty much, that's big tension. Now I haven't looked ahead, so let's see if that's even close. There we go. There we go. Looks like they're doing what I did. There we go. Dun, dun, dun. Dun, dun. Oh, okay. They just went with 2 sig figs, 3,900 newtons, 3935. Now I know if you're new to this and you started to look at it and you were going, oh my God, that's all we did. We just did this. Okay? Piece of cake. Out here.